Good morning and welcome everyone. My name is Tiffany and I'll be presenting for you today. My company specialises in designing networks for local and international clients. We have recently signed a contract to design the network for Smart Pharmacy that has a number of pharmacy franchises throughout New South Wales, Australia. These are the topics that we will cover in more depth today. Smart Pharmacy's business goals and constraints, technical goals and trade-offs, user communities, data stores, network applications and traffic flows, model for addressing and naming, logical network design, routing and switching protocols, and security mechanisms. Smart Pharmacy purchases its products from various manufacturers all over the world. Smart Pharmacy will have its new warehouse in Botany, New South Wales, from where the products will be delivered to each franchise when the stock level of the products in a franchise drops below a threshold. The warehouse will have all the information about the products that are in each franchise in its database. When a product is sold by a franchise, the database in the warehouse will be automatically adjusted. The warehouse will also stream videos about its products and other health information to the video screens at each franchise. Customers will be able to browse through all products of Smart Pharmacy on its website. After selecting a franchise pharmacy and the products, they will be able to pay online and collect the products at the selected franchise. When a product is ready to be collected, a text message will be sent to the phone of the customer. Smart Pharmacy will also appoint a team of door-to-door delivery people all over Australia who would help elderly patients order prescription medication and deliver them from a franchise later. The Managing Director, who is also the owner of Smart Pharmacy, a purchasing manager, storekeeper, logistics manager, and an accounts and finance manager will be located in an office attached to the warehouse. All servers of Smart Pharmacy will be housed in a room in the same office where the network manager will also be located. All internal and external financial transactions will be handled by accounts and finance manager. A highly secure network should be designed for Smart Pharmacy in order to protect client business and financial information. The Managing Director does not support cloud-based solutions. Our technical goals are to build a network that provides a highly secure network to protect client business and financial information that can scale to support future growth, that can be easily managed and monitored, including network performance, faults, configuration, security, and accounting capabilities, that is available approximately 99.9% of the time and offers a response time of approximately 1/10 of a second or less. A network and services that users can easily access, including the ease of network addressing, naming, and resource discovery, whilst containing the costs associated with the development and implementation of the network, including purchasing and the operation of hardware and services. Affordability can be sacrificed to meet strict availability goals, whilst usability can be sacrificed to meet strict security goals. In order to understand network traffic flow, first we identified user communities and data stores for existing and new applications. A user community is a group of employees that can be categorized for their application usage. Additionally, major data stores were also required in order to characterize traffic flow. An important part of any technical design is choosing where to store your data. A data store is a repository for persistently storing and managing collections of data, which include not just repositories like databases, but also simpler store types, such as simple files, emails, etc. In order to document the traffic flow for network applications, we had to first characterize the flow type and user communities of each, as well as the associated data stores. Administrative staff make extensive use of email and web browsers to access information and other typical web services. Customers will be able to browse through all products of Smart Pharmacy on its website. The warehouse will monitor the stock level of the products at each franchise in the database. Client-server traffic is the most widely used flow type as clients rely on servers for access to resources such as storage and application software. These days, HTTP is the most commonly used client-server protocol as clients use a web browser to communicate with web servers. We have provided guidelines for assigning addresses and names to internetwork components, including networks, subnets, routers, servers, and end systems. Without structure, it is easy to run out of addresses, waste addresses, introduce duplicate addresses and names, and use addresses and names that are hard to manage. To meet Smart Pharmacy's goals for scalability, performance, and manageability, we have assigned addresses and names systematically. We decided to use a hierarchical mesh logical topology. A routing module was added to each of the building's high-end switches, essentially turning the switches into fast routers. With this approach, we are able to subdivide the network logically into multiple subnets. We have assigned a private address range to the network. Names play an essential role in meeting our goal for usability. Short, meaningful names enhance user productivity and simplify network management. A good naming model also strengthens the performance and availability of a network. To maximize usability, names should be short, meaningful, unambiguous, and distinct. Users should be able to easily recognize which names go with which devices. So we have included a location code. For example, all names in botany will start with BOT, as most people remember letters better than numbers. Device names will also include a prefix in the name to give an indication of the device's type. For example, we have prefixed router names with the characters RTR, switches with SW, servers with SVR, and so on. Using meaningful prefixes decreases ambiguity for end users and will also make it much easier for the network manager to extract device names from network management tools. We shall avoid the use of names that have unusual characters such as underscores, ampersands, asterisks, and so on, even if the naming protocol allows these characters. These characters are hard to type and can cause applications and protocols to behave in unexpected ways. We recommend a hierarchical design model, which is a three-layered model with a core layout of high-end routers and switches that are optimized for availability and speed. A distribution layer of routers and switches that implement policies and segment traffic, and an access layer that connects users via switches and other devices. Hierarchy and modularity have allowed us to develop a network consisting of many interrelated components in a layered and structured fashion. Using a hierarchical model has helped us to maximize network performance, reduce the time to implement and troubleshoot a design, and minimize costs. Our redundant network design lets us meet Smart Pharmacy's requirements for network availability by duplicating network components. Redundancy eliminates single points of failure on the network and also facilitates load sharing, which increases network performance. We have included dual WAN routers, each with its own internet link for WAN router redundancy and load balancing. If one router or ISP fails, it won't bring down the network. There is a demilitarized zone that contains all the servers that are accessible by the public via the internet. A local services zone which houses the servers accessible within the corporate network by employees, but not by the public from the internet. The access layer switch has two uplinks to the distribution layer switches, which are stack switches with cross-stack ether channels for LAN redundancy. Service continuity is maintained after a switch fails or an Ethernet link fails. An Ethernet switch is a high-speed internetworking device that moves data from one interface to another based on the layer 2 destination address. We will implement spanning tree protocol on switches to avoid loops in the topology. Uplink fast will be configured on access layer switches to improve the convergence time of STP in the event that a redundant uplink from an access layer switch fails. To determine how to reach destination networks, Open Shortest Path First routing protocol uses a shortest path first algorithm. Enhanced Interior Gateway Routing Protocol, on the other hand, uses a composite metric based on bandwidth, delay, reliability, and load. EIGRP will be used in the core layer with redistribution to the OSPF in the distribution layer. We chose to deploy link state protocols because the network design is hierarchical. The administrator is knowledgeable about the chosen protocols, and fast convergence of the network is crucial. The decision to use EIGRP and OSPF was based on the underlying topology, IP addressing design, vendor preferences, and Smart Pharmacy's goals for security, scalability, and network performance. Network security should be multi-layered with many different techniques used to protect the network. Physical security refers to limiting access to key network resources. Critical equipment will be installed in computer rooms that have protection from unauthorized access, theft, vandalism, and natural disasters such as floods, fires, storms, and earthquakes. Authentication identifies who is requesting network services, whilst authorization grants privileges to processors and users. Auditing involves the collection of network activity data to analyze the security of the network. Data encryption is the process that scrambles data to protect it from being read by anyone but the intended receiver. Encryption is recommended to protect the confidentiality of Smart Pharmacy's data. We have placed public-facing servers in a demilitarized zone that is protected via firewalls, and packet filters will be set up on routers, firewalls, and servers to accept specific types of packets and deny all else. In conclusion, our goal was to design a hierarchical, modular, redundant, and secure network architecture based on Smart Pharmacy's business and technical goals. By designing a logical topology before a physical implementation, we have been able to meet Smart Pharmacy's goals for scalability, adaptability, and performance. After completing the logical topology, we designed network addressing and naming models, selected switching and routing protocols, and developed network security and management strategies. Thanks everyone for your kind time today. And if you have any questions, please put them below.